Hi, and welcome to day 3 of Advent of Code. Got about 20 seconds here before the third problem drops. Refresh the page. Got my closure environment here, and just excited to try tonight's problem. Might be trying a few new optimizations, but it's really just going to depend on what the problem looks like. Here we go. All right, spiral memory. Okay, interesting. All right, let's see. 2 grid, each square, spiral pattern, cool. All right, very space efficient. So I need to generate this kind of thing. Requested data must be carried back to square one. Okay, for example. All right. Okay, so it's like, what is the Manhattan distance? Okay. Pretty interesting kind of problem. I wonder, all right, so I could try generating this whole thing. I wonder if how efficient that would be. Let's try just looking at this for some kind of pattern. So taking this, say, and pasting it into our editor and commenting it out, we might say something like, so 0, 1, 2, 1, 2, 1, 2, 1, 2. Okay, followed by, looks like then the next one is going to be 3. Okay, so like the first one is like this, then the next one starts with a 3, goes to 2, then back up to 3, then 4. Okay, and then the lengths of these things are going to be, this one has 1 in it, and then this one has, that would have to be 8 in it here. So each of these are going to be like the square numbers. So this next one, it's got to add up to 25, so it would be 25 minus 8, so like 17 here. So how many, I guess, what are the sums of the square numbers so that we could see maybe what we're working with here? So I could take like a range up to like maybe 25 or something, and then map like multiplying a number by itself here, and then something like, would it be applying the sum? I don't think so, because that's already part of it. So it's basically saying what's the least square number. So maybe like take this and say filter where the number that we have is at least this great, and then take the first one of these. Oh, right, and we're going to just do this for all numbers. Okay, so this is the number, which is, okay, 559. So it's somewhere in the 559th range out. Okay, so where is it? I wonder. Okay, so what we can do is we can say, like, for each number in this range, is there a way to like carry? Okay, so let's take the first. Let's take all of these numbers up to and including 559, and then apply plus to this same thing here. Okay, so we basically say that we have this number, and then we're going to subtract our wait. Oh no, this isn't This isn't quite right. I think, yeah, we just need to take the square of we just need to take the square of 558. So multiply 558 by itself. Take this number. We're going to subtract our input from it. All right, so it's 687 steps in this outer row here. So how do these numbers go? So when you get to the outer thing, it looks like you're going to be something like, so you keep going, so it keeps going like this. So it keeps getting 2 steps bigger on each time you start. So it starts at 1, and then it's going to go up by 2. So we can say something like this. We can say like iterate adding 2 to a number, starting with 1, and then let's make sure that we get the right one here. So this one is going to be so the first number here is basically in the second level of the shell. So the 559th element of the shell is going to be, let's see, I think number 559, like this. Okay. Yes. Okay, so the number, it starts like this, then it goes down all the way to 559, then it's going to go all the way up to, let's see, it's going to go all the way up to 2n. So multiply 2 by 550. See, so this is the 0th. This is the first step out. I'm not sure, there might be an off by 1 here. So basically, we need to take this number, okay. So it seems like, okay, so what is the difference between these two numbers? Start here and subtract 559. Okay, so we can take this and we can subtract that from this difference here. Okay, so it's going to be 127 steps from being 559 or 558 steps. So this is 1. So basically, it's going to be, you got to go up 127 from that point in there. So each of those is going to be increasing your Manhattan distance by 1. So I think that the answer is something like adding 559 to 127. Now, I might have an off by 1 error here. So let's think about it. Okay, so we know that, so this is the 1 by 1, this is the 2 by 2. We know that we're in the 559 by 559. So in the 1 by 1, it's actually 0. So, okay, so I think this is the number, 865. Not the right answer. All right. Well, so let's figure out what could have gone wrong here. Okay, so we know that. Oh, I see what the problem is. The problem is that these squares aren't going up by regular squares. They're going up by like it's 1 by 1, then it's 3 by 3. Okay, so then in that case, let's go back up here and say something like we need to find, so instead of, so we want to say like iterate on adding 2 to something. starting with 1 like this. Okay, then this gives us, let's see if this is the same as before. Okay, so it's the same, it is the same number as before. I think that we just have the wrong number of steps out. So let's see. Let's see. So, okay, so we need to figure out which n this is catching here. So in that case, we want to do something like maybe like a so let's see, 559. So maybe I can just say that's like around, going to be like around half of this. Or I could put in like maybe like a do, just print this thing out. Will that work? Wow, that's pretty slow. But yeah, I think we're just gonna have to wait until. Oh, oh, shouldn't have gotten there already. Yeah, probably. All right, I'm gonna stop this. So basically, the question is, how many times do you need to do this before you get 559? Okay, so I think since we know that we start with 1, take 559. 1, 559, and divide by. Okay. So this is the number of levels out that we are. Okay, so and then we know that the number of levels out that we are is something that you multiply by 2 to get where you start. Right. Let's see. So where was this 1119 coming from? Oh, I think it was this one here. Right. Okay, so we actually want to take 279 here. So so it's saying that when this square starts, we're this many away, and then it's going to go down. So you just take it that many steps. Okay, so start with the 559. That's the Manhattan distance where you started. Then let's see. So it's going to be like this number here, which is 559 steps away. Then it's going to be this number here, 560 or 558 steps away. And we have to take it. Let's see. So is it going to go up and around the corner? I think it will, because we have our 559. We know we're 279 steps out. So I think that we take this difference, and from this we subtract. Let's see, so we're 279 steps out. So we know that we're going to go like, I think half of this. So something like divide this by 2. So maybe like subtract 139 here, getting us to a point 548. Okay. So I think that this splits up into 139 going down, then 140 going back up, then 100 and so it's 279 on a side. So that means it's going to go down for 139 steps and then go up for 139 steps. So, okay. It's the number that we need. All right. Yeah, so let's compare to this one here. So here we start and we go down, down, up, up, down, down, up, up, down, down, up, up, down, down, up, up. Okay, so there's a number of downs equal to the level out, the level out minus 1, except in this initial case. Okay, so I think that means 5 splits 4 and 4. 138, 139, 139, 139, 139, 139. Okay. Okay, this makes sense. 139, 139. Okay. Is this number at least? Yes. Okay. So we know that if you followed all of these steps, so these are down, up, down, which means that after this many steps, your Manhattan distance is going to be at a minimum, which I think we figured out was going to be 278 steps away. So what are the difference between these? The difference between these two numbers is 7. So I think we have to add 7 here, getting 285. All right, let's try 285. Not the right answer. Okay. Well, we could try drawing the could try drawing the circle here. What would something like that look like? I guess before we do that, we just want to check like a bunch of if there are any off by 1 errors. Maybe another way to do that would be to All right, so this many steps down, this many steps up, down, down. So thought it was almost all the way down. It is definitely, is it this many steps away? I think it is because here we're 1 step away. Yeah. Okay. The other way to do this is just going to be to write a function that sort of that maybe takes like our current location and then returns the next location and the number of steps taken so far. So we might define some function f here, taking Manhattan distance m and the number n, and so we know. Let's see. So that we're going to yes, incrementing n is going to be part of it. And then let's see, so the Manhattan distance we know is going to start here. And yeah, so now, so what's the new distance? So the new distance is going to depend on a few things. One is if the number is a square of an odd number. So square of odd here maybe just defining square of odd to be the set of numbers where take this map, multiplying it by itself, and taking 300 of these, which I think would be enough. Okay, and then in that case, what we need to do is we need to say that the new distance is basically just going to be the old distance plus 1. So increment the old distance. Let's see, if it's not the square of an odd number, then let's see. Like in this case here, what is the situation? So we know, maybe we should represent this as like a position. So we might represent this as like x and y. So in this case, what we'll emit is going to be increment the x and leave the y the same. Otherwise, I think, let's see, we could have a direction as well. So like d, the direction that we're traveling in. And then in this case, we would set the direction to be like up. Okay, and then otherwise, we would want to, I guess, move in one direction. So the directions would be, let's see, so up would be, let's say, so x then y. So this down, this left, this right, like this. Okay. And then, so then advancing here is going to be, let's see, you can say the DIRs of your current direction here, map plus to x and y. And then we need some way of getting like a new direction. Yeah, maybe something like this. And the new direction is going to depend on whether we're at one of these corner numbers here, which are, let's see, so let's see, 1, 3, 13, 1, 5, 17, 1, 7, 21. What is the pattern of these numbers here? It seems like, so in one case, you're adding 1 and then 10. Another case, you're adding 4 and then 12, 6 and then 14. And then just looking at this, my guess is 8 and then 16. And 23, 24, 25. Yes. So that looks good. So, all right. And then can I get the next one of these? So it's going to be 25, then 26, 27, 28, 29, 30, 31 for this next one. So in order to get to 31 from 13, you've got to add 18. Okay. So I think I see the pattern here. So we're gonna start with 1. So we need basically like, and this should actually be 2. Okay, so something like iterate adding 8 to something, starting with 1 and taking like 300 of these here. Starting with 2, and then we would also do the same thing, starting with 4. Starting with 4, 6, and 8. Yeah, that seems pretty good. So we could concatenate all these together. Then what? And then for each of these, we're just going to map add just one to them. So let's see, this looks like okay. 1, 3, 11, 19. What is the okay? So this needs to be. Oh, I see. And the reason is that you're adding 8. Okay, yeah. So this is so this is not quite right. What you need is for each of these sequences. You need to do something like this is a sequence, and then you want to do, I think, something like a reductions on plus starting with 1, something like this. Take 300 of these. Let's take just like 3 to start. On 313, yeah. Okay. This is looking good. We're gonna repeat this here. So now we have all the corner numbers. Right. Well, these should, I guess, be taken. Okay, and then so we could make a set of based on concatenating these together, and say something like, all right. Okay. All right. So we got this now. Okay. Okay. I think we're kind of getting there. The new dir is just going to be if the number that we're on is a corner, then we need something like rotate. So up becomes left, left becomes down, down becomes right, and right becomes up. Although I don't think that last one will happen. Okay, so the new dir becomes rotate the current dir, otherwise it stays the same. Okay. All right. And then, all right. So if we do this, okay. So it's trying to read a bunch of stuff here. Let's work. All right. So what have we got? End of file while reading. Okay. Needs to close the let. Let the new dist be. Right. Okay. So close this let, and then we're going to emit. Okay. Here we go. Yep. And then we're going to conj dist dir. Okay, let's see, corner question mark. Okay. Unable to resolve square lot. Okay. lot of these expressions haven't been evaluated yet. All right, so what do we get here? Okay, nth not supported on a long. So it looks like, so, okay, so is that here, maybe? Map V, ders D. Oh, yeah, so we should probably specify in the beginning. So you start at, so our X, Y, and D. We can, let's say something like X is 1, Y is 0, dir is up, and the number is 2. Okay, square of odd. Long can't be cast to an IFN. Oh, okay, let's see here. Map. So seems this part seems fine. Yeah. Okay. Well, I should be able to. Oh, right. Yeah. Instead of this, it needs to be this. Okay. All right. And let's try this. Okay. Now it says 1. So 1 and 0. Now it says 1, -1, and up. Okay. How about take 5, iterate F starting here. Okay, something it doesn't like. So the neuter is this. Take 2. Okay, 3. Okay, so on the third step, it doesn't like something. And saying nth not supported on this type. Okay, what is the actual stack trace here? Okay, in the line in F here. To do this. What if we just printed everything in this step, in each step? Okay, so it's saying 0, 1, up, 2. Oh, okay. I think that this. No, let's see. What is this? So start from this state here. Okay, does take 2 work? So yes. Okay, but then that third one doesn't work. So my guess is, I see what the problem is. Because, well, so in this case, let's see, the first element is, yeah, okay. So this needs to be like, this. Okay, but now looks like there's a different problem. So this one, and then now why has the direction become? Because my guess is that maybe, oh, I see, because the direction has become, got it. Okay, so this actually needs to be, so this needs to be incrementing n, and this needs to be conj the new direction. All right. Okay, all right, I think this is starting to look better. Let's take a stab in the dark here. So if this is what we're defining, well, actually, we're just going to say filter where equals the second thing of this here. And then I'll just take the first of these. Oh no, 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 no. All right, I'm gonna take this print line out. Turn this off, connect again. All right, redefine this. Okay, this says 430 and 0 going. Okay, so 430 is what it's saying. So try to verify this. Okay, so it looks like at a certain point we didn't take a corner properly. So yeah, maybe. Oh. Oh. Let's let's keep looking here. So maybe take 10 from here and see how it behaves. Okay, so this does seem to go right properly here. Maybe we do just need more of these. Here, I'm going to take these parts out. I need them. And maybe just up this just to be sure. Actually, well, yes, it does seem to matter. Okay. Okay, and let's try this now. All right, same kind of behavior. Okay, what if we only go 10 this far in? Okay. All right, so it looks like it is having a problem somewhere in the high thousands. Yeah. So okay, so the the other way of doing this is we could say something like we're going to keep track of steps this direction, left in this direction. Okay, and then say something like instead of corner, if there are 0 steps left to taken in this direction, all right, then rotate. Yep. And then let's see, so we would initialize this to be, let's take a look here, so just 1. And so I think the key of the number of steps that you have to take at each point is going to be like the ring that you're in. So let's see, how do you figure that out? So you basically need to figure out the square of the odd that you are less than. So maybe something like take while, or maybe like drop while taking this thing. So while your number is greater than this thing, and then just take the first of these. So you say something like you're like bounding a square for some number n is equal to this. And then yeah, some like 7, for example. Okay, so that's looking good. So in this case, when you do rotate, what do you say? So basically, onto this is to say something like, if the new dir is not equal to d, then take the bounding square of the number that you're in right now, and so in this case, that would be something like 9. You take the square root of it, and so it would give you something like 3. And then in this case, it's going to be 1 less than that. So the number of steps that you have to take is just 1 less than that. And otherwise, you're just going to decrement the steps up in this direction. And then the only exception here is going to be that if the new dir up, then you have to actually decrement this twice. And otherwise, do this. Okay, so now we take the identification of the corners out of the problem. And all right, so let's see now. Okay, keyword can't be cast to a number. Let's see. Let's see, can we take 1 from here? 2, 3. Okay, so at some point it has a problem. My guess is okay, so this is saying that step 9, you are saying going up. Okay, so it's saying that 2 is at 1, 0, correct? 3, correct. 4. So 4, this is not right. Did I define these correctly? These look right. So let's see. Well, we could say something like 0 steps instruction. Okay. Maybe let's change this to a pond. Right. Something like this. If n is like 9, then you have to go over here. All right. So all right. So step here is just saying. All right. So maybe we should take another stab at this here. So if you start maybe like yeah, I wonder what the problem is. the, well, there are a few places. So let's see. All right, let's break it down to something that's a little bit easier. So, okay, so for this is saying that 4. Okay, so the problem is that we start here. That's good. Then here, this is good. And then the problem is that we're going in the wrong direction. Okay, so that seems like we actually need this to be the new direction here. Uh-huh. Okay. I'll change things. Okay, so now this looks better. Let's try taking 10. Okay, so my guess is that that is a problem here. Square root, subtract 2 from it. But okay, well, let's just see. So take 8. All right, so this is saying that 9 is going to be 2. 5 is saying it's here. Okay. All right. And let's see. The steps left, okay, in each direction. So there's 1 step left in this direction. That goes down to 0, correct. Then this goes up to 2 steps in this direction. But that's after the step has already been taken. So I think this needs to be subtract 2. This. All right. Okay. All right. This is looking pretty solid, I think. Except now we've got to tell it that this is actually supposed to be right, and this is this. Let's see. Well, yep, that's fine because this is going to give us the proper new distance, and then this is actually what we care about here. Okay. Right, and then for some reason, okay, so then it's saying that you're 2 over, 1 down, going up with 1 step left to go. Which means that if I take a couple more, okay. Oh, I see. All right. So where is the problem here? I think is in this new dist, which maybe should just be taken out completely, or like this here. Okay, and then it's saying go up, go up. Now you're at 11, but you got to keep going up. And I think that that is because this part is wrong. So the square that's relevant here is going to be 25. Take the square root of that. That should go down to 5. So we go to the next step here. Okay, then it's gone left too fast. So I think this needs to be greater than or equal to. Right, looking good. Okay, and then so it's saying that at step 14, you're going to be going left and you're going to be exactly 3 steps away. Nope. So, okay. All right, so it's saying at 13, you're at 1 and -3, correct? And then at 14, no, you should be at 2. You should be at 2 and -2. Okay, so is 12 right? 11 says, okay, so 11 is not right. I think, yeah, that what has happened here is the, so this looks good. Got to go right one step. So you go right one step. Hmm. So at this point, so when this is the input to the function, then it says, okay, you got to go right. And it looks like you do. It does. I mean, well, let me load this here. Huh. Well, so it's saying I'm at 1 and 1 here. And then what I expect is I got to be at, expect that I'm going to be at 2 and 1 going up with 3 steps to go. Okay. So then I guess this needs to be maybe like this needs to be up, but then like some kind of handling here where we say, actually, you're going to go right in this one situation. Yeah, and I put this in the wrong place. And now 2 and 1 going up with 3 paces left. That looks good. Okay. And what have we got now? So now we're saying that 15 is going to be 2 steps away. Okay, I'm feeling pretty good about this. Okay, so all right. So let's start this state here. All right, reasonable numbers. Now we need the case where n is equal to this. And it's saying that I got to add 151 to 279, giving 430. Right answer, rank 933. All right, going back to day 3 here. Stress test, clear the grid, store the value 1. All right, they store in adjacent squares. So for the first few squares values, all right, square 1, okay. The sum of the values in all adjacent squares, including diagonals. Oh, I see. Okay, of all the squares that have been filled so far. Okay, that's interesting. Okay, yeah. All right. Well, that one's not going to be so hard. So I think what we can do, basically, we can just use a normal loop for this. So we can have a loop with like, map of states, something like this. And then we'll have like our current state starting, like starting here again. And our map of states might start initially with like, say, 0, 0 mapping to 1. Yeah, that seems pretty good. I wonder if we can generalize this here. So what happens? Okay, so do we have square of odd 1 here? Okay, we do. Okay, so I think we can actually start. We can start with 0, maybe like 0, 0 up. This is this the right starting state here? The answer is no. Still no. We need this to be down. Only one we haven't tried. Left. Okay, so this is saying go to, yeah. Yeah, not sure how to properly fit 1 into this process, so maybe we'll just start in this state here. So first value written that's larger than your puzzle input. Okay. Okay, so we can just say that this is the current state, and yeah, we know that that's fine. We don't really care about this number anymore. So we know that in the recursion step that we are going to like associate the vector of like take 2 from first of the new state, and then we're going to associate a value with that. So we'll say something like value, and then after the current state, we just do an F on state. That should be fine. All right. Okay, now we have to calculate the new value. Okay, so let the new value be something like apply plus to for I in -1, 0, 1, j in -1, 0, 1. We'll take the map of states of the map B plus ij to take 2 from the first of the current state, defaulting to 0. Okay. So back out of the recursion. If the new value is greater than this here, and return the new value, and otherwise will recur. Okay. Well, let's give it a try. So unable to resolve symbol new state. This. Okay. So we just sort of need a let for new state. Actually, no. So this actually is the current state here. Okay, wrong number of args, 2 passed into a SOS. Okay, so a SOS, states here. Okay. All right, so there's a number. Be nice to see a couple more numbers here. So maybe I could do something like put in print lines, but those are kind of, maybe I could put in like an atom or something. Something like swap bang a conj new value, something like that. All right, and then take 10 from a. Okay, so 1, then 2, 4, 5, 10. All right, that's good enough for me. Let's take, this was the value. Which value was it? Oh, yeah, this is it. Okay. All right, rank 475. Okay, so rank in half of what it was from my first star. Let's go to the admin calendar. All right. Yeah, looking pretty good here. Ooh, that's a good one. All right, let's talk about the problem. So this one took me a while. Basically, you have a sort of numbers being filled out in a grid structure, and then the question is where in this grid is a particular number. And I took a couple of approaches on it. One that didn't seem to work was trying to like back out based on the location of the greatest square number that was less than my input. So I'm not really sure why that didn't work. My guess is I was being imprecise with my math. And then I ended up settling on modeling it as a state transition problem. But my solution was just really half-baked. I didn't really have a clear model for a couple of things, like basically keeping track of what direction the sort of mover was headed in, and how to sort of model your direction and your state. So I ended up with this big mess of a function here, and that just required a lot of debugging and wasted time. Yeah, weird sort of helper functions and mathy, confused math definitions and things like that. So yeah, I think it was a good problem. Definitely caught me off guard a little bit, but I think on future nights I'll be better equipped to do these kinds of things. The solution that I ended up going with was yeah. So basically, our little stepper guy has four state variables: x, y position, the current direction, and then I define this thing called steps left in this direction, basically to represent the fact that if you're like say at 14, you know that you're going to be taking like 1, 2, 3, 4 more steps, and then going like taking a left turn. There's another way that I could have done this, which was maybe the direction that you were like expected to go or rewarded to go in part 2, which is to actually fill out the grid. If I had done that, and you can see like this, like basically used a structure like this map of states here, then my algorithm for knowing like when to turn would, or even I think which direction to go in, although I'd have to think about that, my algorithm would become a lot more straightforward, because what you do essentially is a lookup on the map of state, and you say pretty much, is there, so like, let's say, let's say that just randomly I was in, let's see if I can reason something out here. So let's say that randomly I'm in state like 714. Okay. X of 7 and y of 14. So if I'm drawing this out, then I can sort of look at all of the positions around me and figure out from there where I should be going. I think that's the case, because I think that if there is, so I think that if there's something on two sides of me, yeah, if there's something on two sides of me in this state, then I want to, like, so if like this is me, if I'm the dot, and there's something like this here, then does that tell me where to go? I think it does. Yes, I think it says that the next place that I want to go is here. Because the algorithm is always hugging the left wall of the areas that have been fleshed out. And then furthermore, if the only thing behind me, if I look like, like this, then that tells me that the place that I want to be is taking a left turn. So in that case, if I'm going down, then the left turn is here. I think that is sort of, that might be like a more reasonable approach based on the way that part 2 sort of worked out. I think that it's never the case. Let's see. So if you do go around like this, then you find yourself here, and you have it on both sides. Then yeah, you want to continue to sort of hug the left. By moving forward, then you notice that there's only one behind you, and then you turn left. Then go up here. You notice both on both of these sides. Yeah, same kind of thing. So that actually seems like probably a much more reasonable approach. That's something that I think these puzzles do, which is they sort of try to reward you for actually doing the problem, rather than like finding shortcuts that are like maybe not relevant to yeah, like if for example my math approach had worked to get that first number, then it would have been completely inadequate to do part 2. So all right, yeah, that was definitely a fun problem. I'm interested in seeing how folks did on the on day 3 for the times. So let's see. Okay, yep, 4 minutes to get both stars. Yeah, that's pretty good. I have to imagine that other folks took sort of a state machine type approach. But oh yeah, looking at this, yeah, 23 minutes. So still very competitive, but certainly a tougher day. This is interesting. So the player that got both stars fastest was not actually only came in 5th, almost half a minute behind this player, who I imagine got there with the proper mathematical solution. So all right, very cool. This has been a longer video, but thanks for watching, and I'll see you tomorrow.